University of Yamanashi began a massive experiment back in 2005. And they simply started with one female mouse and then just cloned her. So basically they produced the clone of the mouse. Then when the clone grew up, they took its cell and did the same thing again and again and again. In other words, they kept raising mice and kept cloning them instead of allowing them to reproduce naturally. And so starting with the donor mouse, they had the G1 clone, G2 clone, and so on. This was a type of a serial cloning that lasted for almost 2 decades. And at first, things looked great. For the first 25 generations, all of the mice were healthy, had relatively normal lifespans, which for mice is approximately 2 years, and overall the success of this procedure was actually improving.
Head to Little Caesars.
Success of this procedure was actually improving, which is what you see in this initial graph, with researchers even at some point assuming that it might be possible to clone animals forever. But then the success rate suddenly began to drop, and by the 57th generation, the birth rate was only about 0.6%, which was very, very low. And then they reached the 58th generation. Every single mouse born from this generation unfortunately died after just 1 day. And so after 20 years, and after approximately 1,200 mice used in the experiment, all of which actually lived relatively comfortable lives, this lineage hit a complete dead end. They could no longer produce any kind of a viable offspring, and the mice were just way too sick. And so the obvious question is, why? What exactly happened here? And the researchers here found that mice had accumulated a massive amount of genetic damage. And that's because every time there's a cell division, it actually has a tiny chance for a mutation, a mistake in the genetic code that just sometimes happens during division. And in normal sexual reproduction, these mistakes are very often filtered out or are basically corrected through the mixing of DNA from 2 different parents. Yet when you clone something, these errors just keep piling up and eventually become a very large part of the entire DNA. With a study discovering that by the 57th generation, the frequency of these dangerous mutations had nearly doubled. And here they even saw large structural changes in the DNA, including the loss of the X chromosome and the translocation where pieces of the chromosome broke off and attached to another. And as you can imagine,
this is less than 0.00000% of how long the Y chromosome's been around. They have it without recombining. It just proves that the Y chromosome is much stronger than the X chromosome. In fact, the X chromosome is actually the weakest to die out when it starts recombining, so might show the X is actually the weakest.